folks, welcome back to my YouTube channel Code to Create. In this video, you're going to see what is the algorithm naive Bayes. So let's get started. So what is naive Bayes? Naive Bayes is a simple learning algorithm that utilizes Bayes rule. As I've showed you guys in my before video what's Bayes theorem, I'll link it in the description below. It's used for classification problem and for checking the probability how much this is yes and this is no. This is going to be the data that we have. Here we're going to see if the person is going to be playing badminton or not. So here we have overcast, rainy, sunny and total with yes, no, probability of yes and probability of. And this is going to be of the outlook, this is going to be of the temperature and this is going to be of the probability. The formula for this is we're going to use the similar. The formula is Bayes theorem formula, that's probability of B to A multiplied by probability of A divided by probability of B. So it's going to be probability of yes divided by today is equal to probability of sunny. So probability of A is going to be the attribute and probability of B is going to be whether we're going to check if it's yes or no. So probability of sunny divided by yes multiplied by probability of hot divided by yes is going to be 2 by 9 multiplied by 2 by 9 multiplied by 5 by 14. That's going to be 0.031. And now we have to check the probability for no. So it's going to be probability of no divided by today is equal to probability of sunny by no multiplied by probability of hot by no and probability of today divided by probability of today. It's going to be 2 by 5 multiplied by 2 by 5 multiplied by 5 by 14. It's going to be 0.0571. So here there's a small mistake. I have taken 5 by 14 and if you check it out in the calculator it's going to be 0.085. It's going to be 0.071 nearby and we have got 0.031. So here guys I've done a small mistake. I have to multiply it with, it's going to be, it's going to be 9 by 14 and we're going to get 0.031. That's a small mistake in my presentation. So yes guys, I've done a small mistake over here. That's I have to replace 5 by 14 by 9 by 14. That's a small mistake in my presentation. Here the probability of yes is going to be 0.031 and the probability of no is going to be 0.085. And the probability of no is going to be 0.085. Now let's move to Jupyter Notebook and do a practical implementation. And I'm going to create a new Python 3 file. Here we have to import pandas first as for reading the file and everything about the data. And then I'm going to say df is equal to pd.read_csv. Let me move up to the directory where I have this and the data we'll be using is Titanic data. Let me open and show it to you guys. Yes guys, you can see passenger ID, whether the person has survived or no, their P class, name, their gender, their age, their SIB, their parts, ticket, and we have fare, cabin and embarked. So here what we're going to need is their passenger ID, if they've survived or not, their P class, their gender, their age and their fare. That's all we're going to need. So let's move up to Jupyter and read this file first. Let me copy the directory. Let me say /titanic.csv. And now let me show you guys the data set. Yes, here it is. The passenger ID, survived and everything. And now what we have to do is we have to drop all these unnecessary columns. So let's do that. I'm going to say df. I'm going to say df.drop. Whatever we need to drop, that's going to be the passenger ID. And yes, their passenger ID, and then we need to drop their name, and then we need to drop their SIB, then let me drop their patch and then their ticket, and then we have cabin and then we have the embarked. Sorry. Cabin and then their M1. Let's set their axis, else it's gonna show an error. The axis is gonna be columns. So I'm gonna say columns, and we have to replace it. So I'm gonna say in place is equal to true. I mean, we don't need it, so I'm gonna just remove it. And now if you see their survive, their P class, their age, their gender, and their fair. Now what we have to do is we have to fill the null values up. So I'm gonna say x is first we have to, before filling the null values, we have to define the values. So I'm gonna say x is equal to df dot drop. We're gonna drop this survived, and their axis, we have to say their axis columns, and then I'm gonna say y is equal to df of survived. Yes, and now if I show you guys the x, first let me show you, and the y, yes, and we have the none values, so let's replace those. I'm gonna say x is equal to x dot fill now, and inside this we're gonna say x dot mean, and we're gonna do the same to y. So I'm gonna say y dot fill now, sorry, y dot mean, yes, and after this we have to convert this gender of male and female to 0 and 1. We have to get the dummies. So I'm gonna say dummies is equal to pd dot get dummies, and we're gonna get the dummies of their gender. So I'm gonna say df of their gender. Now if I run this, yes, and after this we have to concatenate this up. So I'm gonna say df dot concat, we're gonna concatenate this df and dummies. Let's do that. Oh, it's a pd, sorry, we're gonna say pd, and here we are gonna say df is equal to first argument type of data frame. Okay, we will set the axis, no. Oh yeah, we have done a small mistake. Yes, now it's gonna work out. Columns, yes. If I show you guys, we have their female and male as zeros and ones. And now what we have to do is we have to drop this gender column. So I'm gonna say df dot drop, and their axis is going to be columns, and then we have to completely delete it. So I'm going to say sorry, true. And now if I show you guys, you can see survive, P class, age, fair, female and male. And now what we're going to do is we have to fit this up. Before that we have to import the naive base. So I'm going to say from sklearn dot naive base import Gaussian naive base, Gaussian base, and then I'm going to say model is equal to Gaussian naive base. So let's copy this much. Oh yeah, we have done a small mistake. It's not going to be Gaussian base, it's going to be Gaussian NB as a short form. So NB, yes, and then I'm going to say model dot fit. We're gonna fit this x and y. Value error, it shows a value error, could not convert string to float male, but we don't have this up. Okay, this is just a small error from Jupyter notebook. It shows a value error now too. Okay, so let's do one thing. Let's just define this x and y values again. So I'm going to say x is equal to df, okay, df dot drop. We have to drop the survived, comma, axis is equal to columns. And then I'm going to say y is equal to df of survived, and then I'm going to say model dot fit It's a value error. It contains none. Okay. So before that, let's see the x and y values. Oh, we don't have this though. Okay, what we're gonna do now is we're gonna say x is equal to x dot fill now, and here I'm gonna say x dot mean, and y is equal to y dot fill null values, y dot mean. Yes, and now if I say model dot fit x and y, yes, and then we're gonna say model. Oh yeah, that worked out as I told you guys. And now we have to predict it, so I'm gonna say pred is equal to model dot predict x. We're gonna predict the x values, and now if I print this out, you can see the 0 and 1 values are right here of survived or not survived. Now guys, you might think, where's the probability over here? Where's the topic probability? Let me show you guys. We're gonna say pred Okay, I'm gonna say pred is the model dot predict. This should work out. Type error, yes. It's gonna be of the x prob. Do this, and now if I print this out, we're gonna get all the probabilities. Yes guys, now we know what is naive Bayes and how does it work. Thank you friends. Please do like, share, subscribe and comment below. Bye bye.